Good evening, everybody. My name is Thomas Beutler. I'm the product manager for anterior chamber analysis, biometry, and IOL calculation with Haag-Streit. I would like to welcome you to this webinar on reproducible and efficient biometry in a busy practice with the Eyestar 900 with Pascal Imesch as our speaker. I'd like to inform you about some housekeeping rules to start with. The webinar is going to be recorded, and we do a Q&A session just at the end of the talk. Please use the Q&A section of Zoom to place your questions. Do not use the chat functionality, even though we are going to watch both of them. So I would like to welcome Pascal Imesch. He is the founder and director of the iPark private practice in Bern, which has become one of the largest eye care providers here in the city. He has been in practice for more than 30 years with a large, vast experience in the field, focused mainly on cataract and retinal diseases. He runs his own practice for more than 20 years, providing the full range of services. Pascal Imesch was the first user of the Eyestar worldwide, and I would like to welcome him here on stage and would like to hand over to Pascal. Thank you very much for being with us tonight.
Thank you very much, Thomas. I'm very happy to be here and to talk about my experiences with the Eyestar. Now, I hope this works. So, as Thomas Beutler said, I was the very first user internationally of the Eyestar, and I will tell you what the reason was for me to use the Eyestar. I was for a long time looking for a device to make my life easier. Basically to delegate all my biometry measurements for cataract surgery, which I did mostly with the Lenstar before the Eyestar by myself. I also wanted to have biometry data and topography data available for any patients, not only for specific cataract patients. I'm thinking about my myopia management also. I wanted to have the possibility for routine corneal topographies for any patients, just to screen for any irregularities of the cornea. I wanted also to somehow easily assess the chamber angle of the patients. And I wanted to have that optimized, not only and always thinking about what to do and where to send the patient and what examination to do. That's why I was looking all the time for such a device. I was trying out several devices before that. And when I first saw a very preemptive version of the Eyestar, I was already hooked on, and I probably was kind of a pain in the ass for Haag-Streit, so they finally decided to give me one. One thing was a prerequisite for me for choosing the Eyestar over any of the other devices that are on the market. The examination had to be done easily by any technician. And I usually have the prerequisite that I want a big red button where it's written start, and any technician can just press it and doesn't have to have an extensive teaching before that. I wanted to have a small footprint. We are in the middle of Bern, an old medieval city, and we have very, very little room. I hate all those devices with additional PCs that have all the IT in there. I wanted to have an integrated system so I could just move the machine wherever I wanted to have it. I want to have as little as possible different software platforms that have to have clients, that have to be serviced, that have to have a server, that have to have a communication to our patient chart. And since we are already quite sold on the Haag-Streit platform with slit lamp photography with octopus perimeter. It was a no-brainer to stay on that platform and not open another platform again. And I wanted to integrate that as easily as possible in the standard patient production line, where the patient really flows through until he comes to the doctor. And this is quite easily the case with the Eyestar. You see it here. We have it in the entrance in one of the screening platforms here next to a keratometer and pachymeter. And so the patient sits on the chair on the back and first has his AR key reading, and then you can do an Eyestar either for biometry or only for topography or only for anterior segment imaging, whatever you want to do. We can also put children on there for myopia screening and just do a full biometry. We can do K-case screening. We can do just simple topography. We can also use it simply to make a topography and then use the images for vision simulation and explain the patient why his vision at night is bad. Or we can just do an angle cross-section for our glaucoma guys. I don't know if they really are interested in it, but I wanted to have it anyway. So what I really like about the Eyestar in general, it's point and shoot. This button that you see on the lower part where it's written start, that's the only thing the technician has to press. Everything then goes automated. If everything is fine, you have a smiley, and then it changes to the other side. Internally, you don't have any moving part outside. It measures the other eye. It goes very smoothly, very quickly, and you have a full biometry, topography, keratometry done in less than a minute. So, of course, this is the ideal patient. We all know that not all patients are the same, but usually it works really fast. Then we have, and this is something I like very much in any software, just a comprehensive overview where we see everything that interests me in biometry. So I see in one glance, I see the pupil diameter. I usually do 2 Eyestar measurements, one in meiosis and one in dilation, so I can assess how large the pupil will be for surgery and also to explain to the patient what happens at night. I can see directly the K readings. I see all the length measurements that are needed, of course, and I can assess if those lengths measurements are reliable, which I couldn't do with ultrasound anyway. And even with the Lenstar measurements, you could see the peaks, but you couldn't really judge what those peaks are. And here you see really what you want to measure. So this is the screen that I like very much. You see really, well, he measured really the cornea, he measured the lens, anterior and posterior surface, and you can see that he really measured at the correct part on the retina and not some kind of vitreous floater where the retina was thought to be by the machine. Additionally, the machine gives you really a lot of feedback. You remember maybe the presentation of Warren Hill, where he said that you really have to take care of a good tear film and optimize the tear film before you perform biometry. And the Eyestar tells you that the tear film is bad. You don't even have to think about it. You don't even have to know it by yourself. You have those little red triangles that tell you something is bad, and when you click at it, you can see that these were the mistakes, that you have a bad tear film. Then you have the topography screen. where you see even in 3, 5, and 7 millimeters where the astigmatic axis actually is, which is a big help, especially for toric lenses. Until now, we only had the K readings. Of course, we had a topography additionally, a simple Placido ring topography. But here you really have those zones, and they help you tremendously to tell if the patient is suited for a toric lens or not, or if you really want to do arcuate incisions or something during cataract surgery. You could easily see not only on the image, but also measured by zones, what to do with that patient. And I'm very much more confident, since we have the Eyestar, in recommending the patient a toric lens or not. And then one of the features that are for me an absolute killer argument, not only for cataract surgery, but for the Eyestar and for any patient, is the visual simulation and the Zernicke aberrations that are really easily and accurately shown in this chart. So you have the low order aberrations and the high order aberrations, and all listed here. You can switch them on and off, and then on the right side you see the topography and the vision simulation. Now, this helps you extremely when you have a patient, to tell them, well, you see quite well during the day when you have a pupil diameter of 4 millimeters. So the patient sees directly on the right side what his vision is, and then you tell him, well, if we correct simply your astigmatism, which is the biggest problem that you have, then you will see much better. It's easy to explain to the patient. He finally even understands why he needs glasses, for example, or why he sees better with his contact lenses, even if he's almost ametropic. But then you can also tell him, well, you can have a very good vision if we correct that with the toric lens. However, you have some higher order aberrations, and if your pupil is larger during night, you will see worse. So to the patient, this is really easy to understand. And for me, it's very easy to then talk with the patient what lens would really be suitable for him. If a multifocal lens in that case would really be suitable or not. You can tell, well, even if we correct the astigmatism, you see the low order aberrations have an RMS of 0.4 or 0.5. You can take that away, but then you still have high order aberrations of 0.47. So, and the largest of them, you see them even in the Zernicke. Here in that case are coma. Coma is very disturbing. So the patient will not be happy at night. But when he says, well, I'm not driving at night, I don't care, I want to see well during the day. If I see badly at night, and he desperately wants some multifocal lenses, well, you can discuss about it, because well, at 4 millimeters, it's not that bad. So in summary, the Eyestar cataract suit helps me a lot to quickly assess what kind of cataract surgery this patient will need, what lens would be suitable for that patient, and I can discuss it with the patient easily, and I can even show him how to do that. Additionally, there are some nice features. You can assess the lens tilt. You can even measure it. Honestly, I don't know yet what really to do with it, but we have it. But I repeat again, the measurements of the Eyestar are just really a nice feature to explain to the patient what he has. Even to a glaucoma patient, to tell him, well, you have to take away your lens because it's much thicker. And if you have an artificial lens, it will be much thinner and will have more room in the anterior chamber. You can just show him in the picture how this will look like. So the easy thing is you have really multiple measurements in one go. You have, because you have a better tomography with the posterior surface, you have better lens calculation features. You have, for example, the Barrett measured formula that you can use. It's not only a mathematical model about the presumed astigmatism, it's the really measured astigmatism of the posterior surface that's taken into account. Of course, you have a topography, you have these Zernike aberrations and the vision simulation, and you can really use it, as I showed here, by patient identification. And what's really something really useful, you can also use it for kids, for the myopia model, where you not only enter refraction, but also axial length of the globe. And you can use those measurements of the Eyestar directly in the eye suite for the myopia module also. So then they came up with the AC suite, not only for cataract, but with an extensive screening now also for corneal abnormalities. So again, here you have a very comprehensive screen where you have all kind of different maps that you may need. And then you have, again, several different analyses that you can do. You have a comparative display of both eyes or 2 points in time that you can compare. You can compare even 3 different points in time, so 2 differences, and you can customize those screen. You can even compare absolutely useless things like the right eye of tomorrow with the left eye of yesterday, but it just lets you customize what you really want. And then you can have them graphically displayed and quantify what you want to do. Additionally, you can examine the keratoconus probability with this program. It puts you a best fit sphere on the cornea, and you can have a best fit sphere with or without a 3 mm central exclusion zone, which helps you very much to show if this cornea fits into a sphere or not and may have a beginning conus. Additionally, there is some staging of the Bellin ABCD stages that are automatically calculated. Of course, you will still need your brain to classify those and use them, but still, it's all in there. Additionally, you can make slides through the anterior chamber to assess the angle with one image also. They are not extremely pretty, I agree, but they work. And you can then even measure the angle that you have here in the eye and quantify it, whatever it may be. We just have the AC, the suite that can do this for a couple of days, so I cannot really tell you how useful it will be, but it's one feature that I waited for a long time. So, as I said before, we are very happy that the Eyestar is so small and has such a small footprint and is so versatile. You can attach the screen wherever you want it. And as I told you, and I showed the first picture, we have even a small little image and certificate that we are the first users of the Eyestar, and I'm quite proud of it that we actually did. And for that reason, because I was the first user, I have an extensive experience with the development of Haag-Streit and its Eyestar. And I have to say, during the last years, since we have the very first version of that Eyestar, I have found that people in the development of this Eyestar, they are extremely passionate about the device. They are perfectionist, service-driven. They are always friendly. If I wasn't, they are pragmatic. They just look for solutions. Sometimes they are not happy about their solution, but they found one. And they are constantly really trying to improve, to make it more elegant, to make it faster, to make it more accurate. They are always looking for some little tweaks to make it better. They listen very much to you when you tell them that what could be better. They really want to make this the best device on the market, and I think they are good on their way. It's a really constant and very fast development. So this is my first experiences, well, already a couple of years now with the Eyestar, and I'm very open for questions now. Thank you very much.
Thank you very much, Pascal. So thank you very much for being with us and sharing with us your first experience with the Eyestar. And I have a quick look at the Q&A section. And one of the questions that came in is, did the Cernicke analysis and vision simulation change the way you choose your IOLs?
Oh, very much so. Very much so. I mean, before that, I had basically only a map of the cornea and could, by gut feel, say if that was a suitable patient or not. And I had the K readings for astigmatism. But that was basically it. And with the Cernicke analysis, I can do it much more accurately. I mean, if the patient has only astigmatism and some asphericity, for example, or some quatrefoil or some trefoil, I would probably be quite happy to put that patient's complicated lens in there. If I had a patient with a lot of coma, I would be very hesitant to do that. And without the Cernicke analysis, I simply wouldn't know.
Perfect. Thank you very much. Then another question that came in is, how fast or how well did your technical staff welcome the device? Basically, I guess the question is about the learning curve.
Oh, the learning curve is next to none. I mean, we have an electronic medical record that talks to the eye suite of Haag-Streit. So we basically send the patient from our medical record to the work list. So this has to be taught how to do that. It's one button on the electronic medical record. And then you have, the only thing you have to do is select the patient. So you have, the only thing you have to learn is how to select a patient, press a button, and that's it. And then, well, you have to tell them to look after the patient, that he stays calm, that he has the chin on the rest, and so forth and so forth. But the device itself is a no-brainer.
Perfect. Thank you much. I quickly have a look at the list of questions. Right now it's empty. So wait 1 or 2 seconds if somebody wants to add something there. Doesn't look like so. Well, thank you very much, Pascal, for your information.
Thank you very much.
And I would like to inform everybody that we are having 2 more talks to go. One's going to be next Monday with David Goldblum, and then Wednesday I'm going to talk about the device again. So please join us again Monday or Wednesday next week for another webinar. And in the meantime, I wish you the very best. Have a good evening or a good day wherever you are on the world. So have a good evening, Pascal. Thank you very much for your support and have a good
Thank
evening.
you.
Bye-bye.